G'day, Year Nines. Now, we're coming to the last little group of questions, and these were questions that I picked from the textbook. I'm going to do them all because you can go to the textbook and have a look at the answers for them, and they're all pretty similar. I'm hoping by doing one, it'll give you the intuition as to how to do any of them. So let's start with this first one. We're looking at rectangles. This is an algebra type question. So we start with a rectangle. Let's go to B, and then we might also quickly have a look at C. So it says write an expression for the perimeter of B. So the perimeter is all the way around. So we can just write that by saying it's all the sides put together. It's going to be 6 plus. The next side is going to be 2x plus another metre, so 2x plus 1, plus 6 again, because this side is going to be the same as this side, plus 2x plus 1. Because by the same thing, this side is going to be the same as this side. So that's all our metre. Now we can do a little bit of simplification here. Let's get all our x terms together. We've got 2x plus 2x, so that's going to be 4x. And then we've got 6 plus 1 is 7. Plus 6 is 13, plus 1 is 14. So 4x plus 14 is our expression for the distance, the perimeter of that. Now, that was the expression, was this first one. We've simplified. It says, will the rectangle have the same perimeter for all values of x? Well, let's try it. Let's say, what's the perimeter when x equals 1? So 4 times 1 is 4 plus 14 is 18. So the perimeter is going to be 18 when x equals 1. Let's say x equals 2. 4 times 2 is 8. 8 plus 14 is 22. So it's a different perimeter. So it's not going to have the same perimeter for all values of x. And you would write that down in an exam just to show you. I'm interested, as well as doing the perimeter, let's have a quick look at the area. It doesn't actually ask us, but let's just, rather than doing number 3, let's have a look at the area as well, because this is an interesting thing. The area of a perimeter is length times width. Right, so in this case, the length is 2x plus 1, and the width is 6. And I'm just going to change it around, just because we're a little bit more used to seeing that 6 in the front of the brackets. So now we can expand it. Okay, we can say, okay, 6 times 2x is 12x. 6 times 1, so 6 times 2x is 12x. 6 times 1 is 6. 12x plus 6 is our area. And if we're told that x equals 1, we could work out that the area is 12 times 1 is 12 plus 6 is 18 units. So that's how we can look at those, use some algebra to find the perimeter and area of a shape. Now I want to go on to this next. Now in my class, I've made a bit of a mess here. Just want to give me some more. Now in my class, we had a good look at number 7, so I'm just going to skip on number 8. Now I think if you can do, like, the thinking is the same, so I'm hoping that'll help you either way. So square start with a square. Whoops, we're going to go up here, and there we go. A square of side length x. So we're starting with a square of side length x, but we're increasing it. So it's no longer a square because one side is being increased by 2 meters and the other is being increased by 5 meters. So our square will now become a rectangle. And the longest side is going to be x plus 5. The shorter side is going to be x plus 2. Okay. So now we've done question part A. Draw a diagram of the new shape, labelling the length and the width. Well, if the length is the biggest, they say the length increased by 2 meters, so that's going to be the length here. This one here is going to be the length, and this one here is going to be the width. That increased by 5 meters. So now we ask the area. What is the area of the shape? Well, we know that the area equals length times width. So let's put our numbers in. We said the length is x plus 2, and we said the width x the width is x plus 5. And we're multiplying them together. Now, this also looks like some of the terms we've expanded. So, we can multiply this out. X times x is x squared, so that's the first. Now, the outside, x times 5 is 5x. The inside, 2 times x is 2x plus 2x plus 10. So now it's going to equal, just lost my pen there. Just want to see if I can scroll down a little bit. It's going to equal x squared plus 7x plus 10. Now we come to an interesting question. It asks us, if we just scroll up a little bit, it asks us to say, what is the change in the area? How much bigger has it got? Well, when it was a square, let's use a different colour for our square. When it was a square, the sides were each x. So the area of the square is the side squared, which is going to equal x squared. So what's the change in the area? The change in the area is going to be the x squared plus 7x plus 10 minus the original area, which is x squared. And I probably should write that as a whole new rule. So, right, change in area. If I was setting this out really well, but I'm just running out of room. Well, no, I'm going to do it. I should do it properly. Okay. So let's write the rule. Change in area equals area of the square minus the area of the rectangle. Well, actually, let's make the area of the rectangle minus the area of the square. Okay, that'll tell us how much it has. That'll give us the increase, the change. So if we work these things out, we've got that it's going to equal the area of the rectangle is x squared plus 7x plus 10 minus the area of the triangle, the original area, which is x squared. So the change, the increase is going to be 7x plus 10 because the x squared minus x squared is just going to give us 0, and what's left is 7x plus 10. So that will be the change in the area. Now, these last ones that I've got here, I'm just going to move them down so I've got some more room. These last ones here, I'm not going to do them all. They're again from the textbook, and it's very important. I didn't put them in the revision sheet. They're from page 11, so you can go there to check some of the answers. But the first one is around factorising. So we're trying to look at the common factor of each of these. So in the first one, 2 pi r is a common factor. And once I've taken out the common factor of 2 pi r, so 2 pi r is part of both sides. When I take 2 pi r out of 2 pi r squared, I'm just left with 1r. And when I'm taking common factor 2 pi r out of 2 pi rh, all I'm left with is h. So it's similar to what we've done. We're just looking for a common factor there. Some of these in question 13 are perhaps a little bit more challenging. I'm going to go to 1. I'm just going to go to D over here. So let's say we've got a squared b times 2ab squared divided by 6ab. Now there's a bunch of ways that we can work this out, but I think it'd be good to put all the like terms together. So the only number here we've got here is 2, so it's going to be 2. We've got a squared times a, that's going to give us a cubed. And we've got b times b squared, which is going to give us b cubed. So that's what's the top's going to simplify to, divided by 6ab. So now we can try and see if we can cancel things for both the top and the bottom. So we've got here a common factor of 2. 2 divided by 2 is going to give us 1 at the top. 6 divided by 2 is going to give us 3 down the bottom. Now, a cubed divided by a, so a cubed is a times a times a divided by a. We're going to be left with a squared. And similarly, b cubed is b times b divided by b. We're going to be left with b squared. Now, that looks a little bit funny. And the reason it does is because when we've got 1a squared, b squared, we don't write 1. It's just understood. So our answer is going to equal a squared, b squared divided by 3. Now, I just want to have a look at a couple of these in question 14 because they deal with an important rule. And that is basically that anything raised to the power of 0 equals 1. So let's have a look at a few of these. Number n here, a to the 0 plus b to the 0, that effectively equals 1 plus 1, which equals 2. P over here, 3 to the 0 minus 5 to 0, that's 1 minus 1, that equals 0. Over here for h, 5 squared is 5 times 5, which is 25. 25 plus 6 to the 0 is 25 plus 1, which equals 26. So it's a play on the fact that anything raised to the 0 equals 1.